Okay, this is problem 6-120. It's on page 322. It is commonly recommended that hot foods be cooled first to room temperature by simply waiting a while before they are put into the refrigerator to save energy. Despite this common sense recommendation, a person keeps cooking a large pan of stew 3 times a week and putting the pan into the refrigerator while it is still hot, thinking that the money saved is probably too little. But he says he can be convinced if you can show that the money saved is significant. The average mass of the pan and its contents is 5 kilograms. The average temperature of the kitchen is 23 degrees Celsius. The average temperature of the food is 95 degrees Celsius when it is taken off the stove. The refrigerated space is maintained at 3 degrees Celsius, and the average specific heat of the food and the pan can be taken to be 3.9 kilojoules per kilogram per Celsius. If the refrigerator has a coefficient of performance of 1.5 and the cost of electricity is 10 cents per kilowatt hour, determine how much this person will save a year by waiting for the food to cool to room temperature before putting it into the refrigerator. All right, so let's make some notes. 5 kilograms of food. The temperature of the air in the kitchen is 23 degrees Celsius. The temperature of the stew when it's hot is 95 degrees Celsius. The cold temperature is 3 degrees Celsius. The heat capacity of the combined system is 3.9 kilojoules per kilogram per degree Celsius. The coefficient of performance of the refrigeration system is 1.5. And the cost of electricity, it's still that, is 10 cents per kilowatt hour. Okay, so this is 1/10 of a dollar. Now the stew is cooked, let's see, how many times a week? 3 times a week, so 3 cookings per week. And we're supposed to determine how much money can be saved by allowing the stew to cool to room temperature, just setting it out on the cabinet. Now, this may or may not be all that great of an idea. One of the problems with it is that if you leave the stew setting out, you might forget about it. And so you need it to go down to the 3 degrees Celsius temperature so that you don't end up ruining it and throwing it out, and then it's all wasted. And so the idea of just setting it in the refrigerator is a good one from the standpoint that you won't forget it. However, one thing that's not mentioned in this problem is that actually cooking something hot like that and sticking it in the refrigerator where the refrigerator is cold is a very large thermal load on the refrigerator, and it's actually hard on the refrigerator. And so it's going to run a lot more than it should ideally. So this can be a big problem. So anyway, we can analyze this from looking at the excess energy removed by the refrigerator. So excess energy removed, because I mean, think about it. The pot of stew is going to go, here's our stew, it's going to go from 95 down to the 23 degree temperature down to 3 degrees. You can either take this whole path in the refrigerator, or we can do this part of it in the kitchen air and this part of it in the refrigerator. Now obviously if it's a summer day outside, then this part would be carried by your air conditioner. Okay, so maybe there's not as much difference as you might think. But anyway, the excess would be the amount of energy the refrigerator removes to go from 95 to 23 degrees. Okay, for the stew to go from 95 to 23. From 23 to 3 is always going to be taken by the refrigerator anyway. So basically this is the part that we need to analyze. So that excess energy removed by the refrigerator would be the mass of the stew multiplied by the heat capacity of the stew multiplied by the temperature change of that stew. So let's see, this is 5 kilograms multiplied by 3.9 kilojoules per kilogram per Kelvin multiplied by the change in temperature. So 95 less 23 degrees Celsius. Okay, how come the Celsius and Kelvin cancel? Because they're temperature differences, so that works out. Okay, so this is how much energy has to be removed, and the solution that I made here is from an old version of the book, so I've got to type in the new numbers. Let's see, so 95 less 23. So this is 1,404 kilojoules that the refrigerator has to remove. Okay, Now, the coefficient of performance of the refrigeration system is just the desired output over required input. Well, what's the desired output? QL. What's the required input? Work. Okay? So you got to supply electrical energy to the refrigerator to make it pump heat, in other words. So we could rearrange this and say, well, then the amount of electrical work required would be the heat divided by the coefficient of performance of the refrigeration system. Because look, this is the heat that has to be removed by the refrigerator. So this is just 1,404 kilojoules worth of thermal energy that has to be removed at a coefficient of performance of 1.5. Okay? So let's take the number we got, divide it by 1.5, and see what we end up with. So we have to purchase 936 kilojoules worth of electrical energy to cool this pot of stew down. Okay? So let's go ahead and convert this to kilowatt hours, because that's where we know our cost. So 936 kilojoules. How many kilojoules in a kilowatt hour? That's something you should look up. It's pretty easy. It's just 3,600. So let's see, there are 36. So there's 1 kilowatt hour for each 3,600 kilojoules. Both of those are units of energy, so that should work. Let me double check that, make sure it's right. This what I've got memorized, but I'm more shaky on some of the numbers than other. So the end of the book, I should have that one committed to memory already. Let's see. You should go to the back of your book and look on the inside cover and see if you can see it. Energy. I'm looking under power. That's why I can't find it. Let's look under energy. Let's see. There it is. It's staring me in the face. Yeah, kilowatt hour is 3,600 kilojoules, so that's fine. All right, so that would convert to kilowatt hours. Well, let's convert it to money. Let's see how much this would cost. So it is $0.1 per kilowatt hour. Of course, this is a little bit of an old number. The cost of electricity nowadays is usually more expensive than that in most places of the country now. But anyway, if we calculate this, this is, let's see, divided by 3,600 and times 0.1. Well, this is only $0.026. So this is about 2.5 cents to cool down the stew. But we're cooking the stew 3 times a week. And the question is, how much money could we save over a year? Okay, so let's multiply $0.026 per cooking times 3 cookings per week times 52 weeks per year. Let's see how much we would save on a yearly basis. So times 3 times 52. This comes up to a total of $4.06. Is it worth it? Well, the cost of the ingredients for the stew, probably more than that. So if you leave the stew sitting out once, if you forget once, then you've wasted the amount of money that you would have paid for electricity. Now, from a user, an environmental standpoint, is it better to not use this 936 kilojoules 3 times a week, 52 weeks a year? Probably. Okay, but on the other hand, you have to consider all the effort that goes into making the food that the stew is made from anyway. So that food all has to be grown. How much energy went into that? Is it worth forgetting the stew, maybe 10 times a year or something? I don't think so. Probably not. So the only consideration I would have here to say you should not put the stew in the refrigerator is just the fact that it's hard on the refrigerator. And of course, replacing the refrigerator is not an insignificant cost. So, there's a simple solution here. Just as soon as you set the stew out on the counter, set a timer, right? And that way it reminds you, and you don't forget. But, the point of this is that it's not always something that looks bad from the outset. It doesn't always end up being all that costly or all that ridiculous. It's helpful. And it's helpful to have a sense for how much energy, how much money, what are we talking about here? What's the size of this thing? And one of the reasons for taking this class is that you don't have a feel for those things when you go in the class, most likely. Okay, I don't have a good feel for how much energy I use, for example, on a daily basis. I'd like to know how much energy I use. And so I can calculate it now, of course, but getting an idea of how much energy is used in various things is valuable. It's good to have a handle on those things.